Solving right triangles, Algebra 2 trigonometry regions. This is going to be very basic trigonometry stuff, things that you actually learned back in Algebra 1, how to find the length of a right triangle or an angle using the basic three trig functions, sine, cosine, tangent, and our graphing calculators. But it's been a while since you did this type of math, so it's worth it to recap it before we get into some more advanced trigonometry. So the two things we're going to be using are how to create a trig equation to find a triangle side length requires function theta equals ratio, and it's basically function angle equals ratio. Something like sine of 30 degrees equals, 1/2, something like that. But I'll talk more about this when we get to an example. But a function simply is your sine, cosine, tangent. Theta is your angle, and your ratio is, this over this. And the ratio is dependent on the function. If I'm using sine, then I have to do opposite over hypotenuse. If I'm using cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. We've talked about, those three basic things. And this is what you use to find a side length, and then we cross multiply. Again, you'll see it a little bit better when I get to an example. Now, when it comes to an inverse trig equation, we use this to find angles. It's set up very similar as far as it has a function, a ratio, and an angle, but instead of a function, it's an inverse function. So instead of sine, it's what we call inverse sine, which we obtain by doing second sine in our calculator. So let me show you what this stuff would look like. Well, first of all, let me give you a quick example right here. So sine 30 equals 1/2. That's, function ratio equals angle. Sine of 30 degrees has a ratio of 1/2. Now, what you'll see is we'll be setting something like this up where we'll be missing a part of the ratio, and we'll cross multiply in our calculator to get it. The inverse trig equations, instead of sine theta equals 1/2, it would be inverse sine 1/2 equals 30. So inverse sine, and we've seen this symbol before when we did functions like f of x, g of x. The little -1 looking exponent stands for inverse, and so we see that, and you see it on your calculator. Like if you look above sine here, the sign with the little -1, that's your inverse sine function. So when we need to do inverse sine, we only need to ever do inverse functions when we're finding angles. We do regular functions to find lengths. But anyways, so we're going to be setting stuff up like these. So let me get to some examples. In right triangle BCD, BD is 12, angle C is 90, angle B is 47, find DC. So I'm gonna label this here X. And so if this is the angle I'm using for perspective, you want to figure out first what ratio you're doing, because we start off by determining the function. So am I using sine? Am I using cosine? Am I using tangent? What do you have here? Now, first of all, this 12 is opposite the 90 degrees, so that is the hypotenuse. So what is x? Well, x247 is opposite that. Now, we know the hypotenuse is the hypotenuse no matter what. But the legs of the right triangle are either going to be opposite or they're going to be adjacent depending on what angle you're using for perspective. So if I'm talking about this angle over here, D, then this side would be adjacent. But because I'm working with the angle I have, B, 47, it's opposite. Because it's opposite, it's across the triangle. So I'm working with opposite, I'm working with hypotenuse. That means I'm working with sine. So you first determine the function. And I just figured out it's sine. What angle am I using? 47. So we start off by figuring out function theta. Well, we just figured that out to be sine 47. 47 was given to us, but the sine we determined by what sides we had. Then the ratio. Well, the ratio for sine, remember the sa or so, ka, toa, tells us that sine is opposite over hypotenuse. And so that would be the opposite side, which is x, over the hypotenuse, which is 12. So this right here is our complete trig equation of function theta equals ratio. Now, I simply cross multiply. And I'm doing 12 times sine 47. I'm going to let my calculator do that work for me. Now, one thing you need to make sure on your mode is that you are on degree. Because if you're on radians, and we're going to learn about radians later on in this chapter, but we want to be on degree for now. So make sure you're there, because if you're getting weird numbers, you're probably on the wrong setting. And I'm doing 12 times sine 47. It's important that you do 12 times sine 47, and not the other way around, because I'm not actually multiplying 47 and 12. I'm multiplying sine 47 and 12. So if you do 12 times sine 47, you're going to get that. But if you did, say, sine 47 times 12, it's going to give you something really weird. So make sure you always do like the function and the angle, the sine 47. That's got to be one piece, and it's 12 times that. And a good way to avoid that is just always put that side measurement before you do the function theta. So times sine 47 is 8.76. And what does this question say? Round to the nearest tenth. So that would be 8.8. And so x equals 8.8. That's basically it, but let's practice a little bit more. This one has an apartment building over here, and it's saying that the angle of depression from the top of the building is 38. So it's saying this angle is 38. And that's actually not an angle of the triangle, right? It's not this angle, it's not this angle, it's not this angle, but it is at the same time, because if you remember back from geometry, that would be called alternate interior, because I know that the horizontal line is parallel to the ground. And so if they give you an angle of depression, there's two things you could do. A, you can do alternate interior like that, or you can know that, well, this is a 90-degree angle because this is vertical and horizontal, so they have to add to 90. And so 90 minus 38 will give me this angle, which would be 52. And so I could actually use either one of these now. They give us the 80 down here, and they want to know the height of the building here. All right, let's use the 52 this time. So I'm going to use angle 52, and I could do either one. Now, my function might change, but so there's a couple of ways to do this, but I want to use 52 degrees. So what function? Well, from 52, 80 is opposite. It's across from it. And my hypotenuse is over here, and that has no measurement, so that's not being used. And this is the adjacent side. So I'm working with opposite of 80, adjacent of x. That function, opposite and adjacent, is our tangent function. So I'm looking at tangent of 52, right? So it's the function, then the angle, equals the ratio. And tangent's opposite over adjacent, so that'd be 80 over x. 80 over x. Put this over 1 and cross multiply. You may notice this question is slightly different because in the previous one, x was in the numerator of our fraction, but here it's in the denominator of our fraction. It's not a big deal. We're still going to cross multiply, but you're going to have one extra step because here we had 12 times sine 47 when we cross multiply, but this time we have x times tangent 52. So multiplying that, you can't because it's x. So you get x tangent 52 equals 80 times 1 is 80. And so the extra step here is now to solve for x, I need to divide by tangent 52. And so I do 80 divided by tangent 52. So basically what's going to happen is when you see x in the numerator, it's the side times function theta. But when you see it in the denominator like this, it's the side divided by function theta. So just make sure you don't confuse the two. And so we have 80 divided by tangent 52 to get our answer of 62.5 to the nearest tenth again is going to be 62.5. All right, one last thing I want to show you. These are finding sides, but it's a little bit different if you want to find an angle. So this question gives us here, I'm not going to bother to read it to you, you can read it yourself, but it's given us this length of the hypotenuse is 50 and this antenna is 30. It wants to the nearest degree the measure of the angle the wire makes with the ground. So here's the wire, here's the ground. It wants this angle. So here's our theta. And it wants to find an angle instead. Well, you still set it up the same way. I'm using this angle now. 30 is opposite it, and 50 is the hypotenuse. So you figure out the function. Opposite hypotenuse is sine. So sine theta is the angle I'm using. I don't have a number there because I didn't define it. Equals a ratio opposite over hypotenuse is 30 over 50. So what's different about when you're finding sides and angles? Finding sides, you have an angle missing part of your fraction. Finding angles, have a whole ratio missing the angle. And what we do here is what we see from the notes in the beginning is to solve for angles, you have to do this inverse trig function stuff. So that's where that comes from. So I need to alter this equation. Instead of being sine, I need it to be inverse sine ratio. So inverse sine 30 over 50 equals theta. And to get inverse sine in my calculator, instead of hitting sine, I have to hit second, then sine. And I see the little -1 there. It tells me I'm doing inverse sine. And I simply type in 30 divided by 50. So when you're doing an inverse function, it's not any harder. It's actually probably a little bit less work. So there's no cross multiplying or no multiplying or dividing at all. It's simply just second function and then type in the ratio you have. And that'll get you your angle. So 36.8. And what did we want again? Nearest degree, 36.8 would round to 37 degrees. So theta equals 37 degrees. So that second key, that inverse function, that's restricted solely for finding these angle measurements. So that's the only time you're going to use that. All right, we'll practice this tomorrow.